Yeah, I'm Mohammed Sharifur Rahman, and with me, Professor Girijesh Prasad has done this research work, and we are both from Ulster University, UK. And the research topic is a comprehensive study of machine learning method to increase the prediction accuracy of classifiers and reduce the number of medical tests required to diagnose Alzheimer's disease. Okay. Actually, our goal of the research was to simplify the diagnosis process for the Alzheimer's disease without sacrificing the accuracy. And why we have done this research is Alzheimer's disease is a deadly disease, and 1 in 14 people over 65 years of age and 1 in 6 people over 80 years of age suffer this Alzheimer's disease. And the disease detection process is time consuming, and it requires lots of tests. And manually detecting the disease is not that easy. It's difficult sometimes and also wrong sometimes. So with the help of clinical diagnosis and cognitive test data set and the help of artificial intelligence, we can detect it automatically. So we tried to do this and to improve the process. So what did we do? We used a mixed forest algorithm for the data imputation where it was required, because there was some invalid data we got. So we had to replace those data, and there were some blank data. We had to reproduce the data through some algorithm. So we used the mixed forest algorithm for that. And we used both the feature selection algorithm to select the features. That means we had 30 features. So in between these 30 features, we tried to take the important features with the both the algorithm. Finally, we used random forest classifier for the classification purpose, and we tuned it. And there were actually 6 distinct type of data with 30 different features. And we used all these 30 features at the beginning of our test. We used all together. Then in the last part of our research, we used only different types of data. That means we split them based on the attributes and tested them using the customized RF classifier. So we used the data from the Alzheimer's Disease Neuroimaging Initiative, ADNI. We used we used R programming language, and we used the R Studio to test the data and also generate the result and analysis. Our testing measure was through confusion matrix. What was our achievement? Actually, we successfully could achieve 94% accuracy rate in prediction using only 4 features out of 30 commonly used features. That means we could reduce some test number also. And only neuropsychology assessment features we could get up to 94% accuracy rate. That's our outcome of this research. So if we go in deep, yeah, we had 30 different features in the data set, and 2 features was about the demographics of the patients. 10 feature was about the medical history. 1 feature was about the genotype, and 4 feature is about neuropsychology assessments. 2 feature was from the blood test, the lab report, and 1 feature was the clinical diagnosis. The data quality we got was not bad. Actually, we didn't find any null value there. We have found some invalid value, but we replaced them with misforest algorithm. But there was a class imbalance. So we used smart algorithm to balance the class. The data we got was taken from 862 participants, and their age was from 55 to 96, and the data was collected from 2006 to 2014. So it's relatively new data, we can say. Our research state was like we collected the data, we analyzed the data, then we pre-processed the data, and then the model preparation and tuning phase came. We tuned our RF classifier to its highest performance. Then we selected the features, and with different set of features, we tested our tuned RF classifier with them, and we judged their performance, and after that we analyzed the whole result. So if you see the right side of this slide, there is a graph. With this graph, you can see that there are 30 different features we used. Here we call it attributes. Within these 30 attributes, you can see 4 attributes are clearly distinct from others. These 4 attributes are contributing or influencing our detection rate strongly, and the other features also contributing in a way that the automatic feature rejection was not possible, because you can see that other features are closely related to each other, and more or less they are contributing or influencing the result. So automatically with the Boruta feature selection algorithm, we couldn't drop them. We only could drop 2 features that you can see the red marks here. So here you can see the red 2 features. So we could only reduce 2 features from the feature selection algorithm. So in this way, our research was progressed. We tuned our random forest algorithm. We selected the M-try using different tests, and we found that with 5 M-try, our OOB error or out of bag error was the lowest. Then after the 5th M-try, it actually increases. So we stopped till the 5th M-try. So we use the 5th M-try for the RF classifier. And also you can see in the right graph, we tried to reduce our class 0 and class 1 error up to its lowest point, as well as the OOB error. Our classifier was tuned until we get the 97% accuracy rate. Here you can see in the right lower part, You can see the ROC curve. ROC curve is a very good indicator that our RF classifier was doing very well, and our AUC was 97.22%. It's very good. So now this is our research outcome. As we have already said that we used the confusion matrix to measure the performance of the classifier. And there are three different indicators in the confusion matrix. They are accuracy, precision, and the recall. With the accuracy indicator, we judge the true positive and true negative over all the tests. With the precision, which has the true positive over true positive and the false positive. And with the recall, we measure the true positive over the true positive and the false negative. So in our case, in Alzheimer's disease detection, accuracy and the recall is very important. So we can see this graph. We we also did the PCA or principal component analysis with all the 30 features. Here is the result. If you see, the accuracy is the blue line with only 2 principal components we could get, and up to 92% accuracy. Then we get 93% accuracy with 10 principal component, but to get the 96% accuracy, we had to use 28 principal components. So it's actually very high number. So with this PC analysis, we couldn't get any specific outcome. It's not worthy enough. So we use the traditional process now. The performance of the classifiers. There are actually 6 different type of classifier and data set. Like we tried with non-tuned RF classifier with scaled data. Then we tuned our RF classifier used with scaled data. And after selecting the feature selection done by Boruta, and we used with the scaled data. And all 3 things we have used with the original data also. We know that the random forest algorithm doesn't need the scaling. So we tried with scale data also and original data also, and we found that our tuned RF classifier worked best with the original data, and the accuracy we could achieve was 96.05% with the tuned RF classifier, and the precision rate was 97.29, and recall was the same. And so we could get the best with the whole data set up to this mark. That means the accuracy we could get was the 96.05%. But our main target was to reduce the test number. So if we could reduce the attributes or features we have used, we can reduce the test number. That will reduce the time and also the cost of identifying the Alzheimer's disease. So what we did, we manually divided our features into 3 different type of features, like medical history data, neuropsychology assessment data, and the third class was like blood analysis and APOE genotype data. So these are the three different feature sets we use. And we used our best classifier with these three different feature sets. And then we get this table. Like with only the medical history data, we could 67.21 point something, and the recall was 82%. But with neuropsychology assessment, we could get 93.68% accuracy. Precision was 95.66 and the recall was 95.66. And with the lab test data, the blood analysis and AOP genotypes, we get 66.6% accuracy rate. Precision was 96.42 and the recall was 77.47. So here we can see that the feature set that's related to neuropsychology assessment, the four features we used for this could give us up to 93.68% accuracy. That's a good accuracy rate, I will say. So this is our achievement actually. With only the four four features, we could get up to this type of accuracy rate and also the good recall rate. So this is the representation of that table. You can see the accuracy. In terms of accuracy, with only neuropsychology assessment based data, we can get up to this much. If we take the precision as our identifier, then we also get the best result with neuropsychological assessment data set, and also the recall rate with the recall. This is actually very important indicator for the Alzheimer's disease detection. We also get highest recall rate with neuropsychology assessment based data. So this was our achievement. Next is the conclusion. What we get with this research. With only neuropsychological assessment data, it is possible to detect Alzheimer's disease up to 94% accuracy rate. And the disease like Alzheimer's, actually for this disease, the recall rate is very important, as I have said it before, and we could get up to 95% recall rate with only this neuropsychological assessment data set. Only four features. So we used only clinical and cognitive data set, but in future, the other available data set can also be included into the research. And we limited our research into binary classification. However, mild cognitive impairment can be separated from the Alzheimer's disease detection to test the multi-class classification also. And the recommendation is like only random forest categorization technique was employed here to evaluate performance with just the neuropsychological assessment data set. We should test the additional well-known classifiers to using the same data set to see how the accuracy, precision, and recall works. So actually, our achievement is like 86%. With 86% of less data, we could achieve the accuracy, which is only 2.37% reduced. That means 93.68%. So this is the end of my presentation, and I'm open for your questions.